All right, 2 more examples and we're done with the EVT. And we move on to second derivatives and what they tell us about our graphs. So example 5, we have a lovely chain rule question. And of course, now we've got some exciting stuff. We've got some trig mixed with an exponential. And we're asked to find our max and minimum values on 0 to 2 pi. So first things first, the question I asked myself just a little bit ago when we had the 2 sine minus x, if we compose 2 continuous functions, we're still continuous, right? So we are continuous, we've got our closed interval, the EVT applies, we can go ahead and do the candidates test. Because exponentials are continuous, right? And defined on negative infinity to infinity. Sine is also continuous and defined on negative infinity to infinity. And in this case, we're only caring about 0 to 2 pi anyway. So let's go ahead, candidates test. I'm going to do my green. I've been keeping green for critical values. If you haven't noticed, my very anal retentive, keeping with that trend. Critical values, we need to find our first derivative. So here's our chain rule. E to the sine x is the derivative of e to the sine x at the beginning, right? That's the derivative of the first. Derivative of e to the x is e to the x. Leave the inside the same. Times the derivative of our inside function, which is that cosine of x. Here, I'll be good and use some parentheses around my arguments. All right, and now, again, these will never be undefined because the domain of all of this is negative infinity to infinity. Composition and multiplication or product of functions doesn't change that. So we're going to set this equal to 0. Well, we know zero factor property. That means one of these two things that we're multiplying together equals 0. Now, e to the sine x, e never equals 0. It has a horizontal asymptote. Remember, this is that one where if you didn't recognize that right away, you would be setting this up, taking the natural log of both sides. Ugh, gross. I guess I'm not even going to write the natural log on that side. I know the natural log in e. They're inverse functions and one of another, so I'll just end up with a sine x. And then you'd have the ln of 0, and hopefully recognize when you tried to type that into a calculator and got out an error, you did something wrong, and that is that e has a horizontal asymptote. This will never equal 0. We can basically ignore this little piece. I don't like how that looks. I'm going to write doesn't equal 0. Ugh. My computer does not like when I'm uploading and making videos simultaneously. Okay, cool. And cosine of 0, well, that's easy. Cosine equal to 0, right? Cosine of x equal to 0. I say easy, but you know me, it's not. Pi over 2 and 3 pi over 2. One day I won't have like long pauses before I start pulling out trig values. But it's really for the best, right? I made it through a math degree and I still don't know my unit circle. I have to think about it each time. So here we go. We got our 2 critical values. We also have our 2 endpoints. So let's make our cute table. You guys know the drill. All right. I'm going to do my endpoints off to the sides because it brings me joy to have these things in order, to think about what's happening. I truly have no idea what the graph of e to sine x looks like because the periodic bit with the e, I'm excited. I'm going to put this in Desmos afterwards. If you're not excited by like, I wonder what the hell this graph looks like, I don't know. I can't help you because this brings me joy. All right, we plug in 0. We get e to the sine of 0, which is sine of 0 is 0, she says, which is 1. All right. We could also do this e to the 2 pi is the same freaking thing because we're back at the exact same point on the unit circle. That's the period. So also 1. Not e to the 2 pi. Oh my god. E to the sine of 2 pi, which is 0. There you go. Cleaning it up. Cleaning it up. Can't talk and write math at the same time. All right. Now I have to think about what sine of pi over 2 is. That is the maximum value for sine. So that is our 1. Yes. So there we have an e. And 3 pi over 2, well, that's e to the negative 1. That's our minimum value for sine. Oh yeah, I was about to say, like, why didn't we get the other 0? I'm like, I want the 5 key points. This is me just being a monster. This is 1 over e. Okay. So another one, our 2 trig ones have worked out this way because of the way the trig functions that we've chosen. We've done sine both times, and sine hits their minimax inside of that 0 to 2 pi. If we had done a cosine, we wouldn't have had that same issue. But we can see here, maximum is E. E is 2 point something. Don't ask me what, 2 point something. And then our minimum, 1 divided by 2 point something is lower than 1. So those are our max and min, and we could write that out. The absolute minimum, I can't spell, is E at x is equal to pi over 2. Look at how fancy we look using all sorts of things that aren't numbers. And our absolute minimum, did I write minimum? Y'all, I got so distracted by my inability to write that I didn't write the right word. Max. I used green. And our absolute minimum is 1 over E at x is equal to 3 pi over 2. So there's our absolute max and min. I did say I'd throw this in Desmos, and also maligned you if you did not have beautiful curiosity about what this thing looked like. E to the sine of x. I'm excited. Oh, she's cute. She's cute. We got like a little exponential growth up until that maximum. And then we get the periodic piece. That's pretty. Let's go ahead and use our 0 less than or equal to x less than or equal to, I did a negative, not less than or equal to, 2 pi. So we're only looking at this section and verify, yep, pi over 2, we have E, which is apparently 2.718, blah, 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 blah. And at 3 pi over 2, we have that. So let's go ahead, I'll even make sure. I'll be really cute about this. Pi over 2, let's do a comma, E, there's that point, our maximum. And we had 3 pi over 2. Let's make that a point. And let's throw in our 1 over E. Oops. There's a minimum point. So we can verify that those decimals that we saw on the graph are the same thing as our E and 1 over E. Cute. Done. I love it. One more question.